Hello, thank you for joining today's webinar. My name is Grigory Trofimov, Senior Solution Engineer at Parasoft, and today we're going to talk about performance testing and how service virtualization can help resolve some of the key challenges that give us stress about performance testing and how we can use simulation to aid us there. If your view of the slides or the demo appears a little blurry, please be sure to adjust the video resolution in the BrightTalk window in your browser. It also helps if you maximize the presentation to full screen. And if you have any questions or issues with the broadcast, please submit your comments in the Q&A area. Also, if you have any questions during the presentation with regards to content or technical questions, please be sure to submit them as well, and we will address your questions in the Q&A section of our presentation today. Preparing your software application to handle peak loads and high volume conditions is vital, whether your business is seasonal operations like e-commerce during holiday season, a ticketing system for big events, or a streaming service hosting a famous sports event, or a financial institution. Load and performance testing, along with simulated test environments, is the key to success. And in today's webinar, we'll discuss how we can reuse API tests to integrate load and performance tests into our CI/CD workflows, how we can simulate real end user experiences without the cost of complete performance testing environments, and how we can leverage virtual data for on-demand performance testing and bypass the constraints of production data. But first, we'll talk about why we get stressed out with performance testing in the first place. What is the challenge? Why it's so important? Um, and then we'll talk about how we can optimize our performance testing strategies using service virtualization, detect performance bottlenecks early, test reliably, and simulate real user experience. So let's start with performance testing. So why do we do performance testing? Well, in terms of user experiences, in terms of how we experience technology today, the most important thing and the most important part of generating revenue and creating value for users is really the user experience, and that remains to be the case. There's really nothing that replaces a good user experience. And on the other hand, we all know that a bad user experience can really turn somebody off from a product or a company, or a particular feature. We all have preferred airlines. We all have preferred hotels. We all have preferred streaming platforms. These things really have manifested themselves in our hearts and our minds based on the user experiences that we have with these products, with these tools. Interestingly enough, with that in mind, and with how much we know about the importance of user experiences, overall user experiences have been going down. Outages are trending higher and they're becoming more expensive. Uptime Institute actually did a recent study on this and found that we are experiencing more outages, and outages on average take longer to fix. They're also more expensive. So for an organization, that is. So that's actually an interesting trend, and that's a trend that goes back, almost 20 years. So it seems like it's a consistent trend. It seems like something that has not been addressed sufficiently in the industry. And interestingly enough, it's still legacy data centers and network uh, stability that are continuing to be the main factors and main contributors to driving these performance issues. Gartner actually quantified the cost of poor performance for an application in 2014. So almost 10 years ago, they they pegged that at about $5,600 a minute, or just a little over $300,000 an hour. So that's actually pretty sufficient, right? That is a large number for an hour of downtime. Um, on average, an organization may experience up to 87 hours of downtime, and that means that 30,000 times almost 90 hours, you're looking at close to $30 million, right? So that is that is quite a number, right? Anytime if you're having a conversation, about prioritizing performance testing, about the criticality of your test environments and being ready for performance tests, or uh, enabling some of the flows that we're going to discuss today in today's presentation, it's pretty easy to bring up these numbers and justify the value of implementing these strategies. And we really don't have to dig deep to see evidence of this. It, every year there's a high profile event that we see, whether it's a streaming platform that can't handle a specific event or a specific show, or a reveal, or an airline that is not able to facilitate air travel during the holidays. And I'm sure this year, with the holidays coming up here in a few months, in a couple of months, we're going to have another high profile scenario. We're going to have another name, and something that we can reference in the future and say, let's try to avoid this. An interesting quote. Um, If a page doesn't load after 3 seconds, the user will abandon the page. If a page doesn't load after 1 second, the user will be angry. And I think this is an interesting quote because it speaks to a number of things. It speaks to the way we kind of evaluate user experience, and it also speaks uh, uh, to how that evaluation and that metric is really kind of subjective in that sense, right? We may have SLAs that we need to adhere to, but at the end of the day, driving the user experience really comes down to validating it at the user level. And that's it's one of the core challenges with performance testing, and kind of some of the other challenges, and how it all culminates in this quote is that number one, performance testing traditionally is something that we do later in the software development lifecycle. There's a number of contributing factors to that, why we do that in the later stages. But the matter of fact is, when we identify defects, when something is not behaving the way we'd expect it to, obviously it's much more expensive to fix it at that stage than it is in the development and refinement stages of a particular feature or a particular sprint or a particular release. The other challenge is realistic testing. So unrealistic testing will absolutely spearhead, or it will spearhead your efforts, your development efforts. It will have you chasing defects that aren't there. It will have you trying to understand edge conditions that are not realistic, that would never be experienced by your real end users. And on the other hand, you will probably be missing real scenarios that are difficult to achieve, either due to the fact that your test data is not available across your environment, or the environment itself has some stability limitations, or limitations with various sandboxes or third-party applications. Those things all contribute to us having unrealistic performance testing scenarios. And then finally, end user experience validation can be subjective. So, how do you measure user experience, right? You can measure page load times, you can measure individual API calls and things like that. But at the end of the day, everything has to be cohesive. Everything has to sort of work together. And as a user, you have to have that end-to-end uh, good experience, while also in a performance test being able to stress the application and apply necessary loads, and get the application into a realistic state of stress. So, as we talk about performance testing, let's kind of just briefly talk about different types of performance tests that we do. These are not all the performance tests that exist out there, but these are kind of your core core strategies in terms of performance testing your application. You have soak tests, which are really there to test the endurance of your application. Right, you're not looking to break the application, but you're looking to understand where there's potential degradation over time. We have peak tests. So here is, where we make assumptions about what is the peak load for our application. Perhaps we are, a uh, some sort of education courses catalog, and during registration times, we would experience peak usage within our application. So we want to be sure we're prepared for that. A stress test is when we're actually looking to understand the limitations of our applications. At what point will the application cease to function properly as we increase the load? And then, of course, a spike test is where we uh, where we essentially spike the number of users, try to generate a very large number of users, and observe the behavior of the system. Again, the goal is to determine whether or not performance will suffer, whether the system will fail, or if it'll be able to actually handle these dramatic changes in load. So with that in mind, for today's presentations, we will talk about performance test automation, how we can shift left our performance tests. We'll talk about test data generation and just general strategies that we can implement for test data and environment stability. And we'll talk about load simulation from an end user experience validation perspective. So what we can do with our environment in order to create the most realistic environment for our uh, end user experience validation tests. So let's talk about that first point. And for that, we kind of just want to describe what our typical flow looks like, or a sequence of events looks like, either during a sprint or a release or a particular feature implementation. Different organizations will have different schedules at which they do this, but the cycle more itself is fairly consistent. So when we have something new that we're rolling out, or something new that we're developing, we design it, we prototype it, we develop and refine it, then we test, and then we implement or release. From a testing perspective, we typically don't start testing until maybe the later stages of prototyping and early stages of development. If we're following certain best practices like TDD or BDD, we may be able to push some of these things a little bit earlier out. If we have a strong uh, test automation practice, and we're able to run some of the later stage uh, tests in the earlier stages of our SDLC. Obviously, that helps us as well. But typically, where we do performance testing is kind of at these later stages, and the main reason for that is, well, it's not that easy to configure a performance test when you don't have anything to test, right? So without a test environment, without a performance test environment, without really testing, a lot of organizations will test in pre-prod or even prod for realistic scenarios. Without having all that together, without everybody kind of lining up to do a performance test, you're just not able to do a full scale, stress test or peak test, right? Um, so the goal here is really to extend that window a little bit, right? And actually do some level of performance testing at the earlier stages, where we can actually implement meaningful fixes, and we can implement changes maybe to the way we've designed a particular feature or a particular service. Uh, it, it's much easier and much cheaper to make those changes then than it is after we've done all of our functional and regression testing, and when we're doing our manual testing, right? If we have to make changes then we have to do all of our functional regression testing again, and that typically sets us back in terms of release and delivery time. So a way to do that is, of course, through test automation tools. So by having the right test automation solution, you should be able to leverage your UI tests, your API tests, your backend tests for performance testing. That's something that we're able to do with Parasoft SOA test. So Parasoft SOA test allows you to do all these different types of tests, and actually incorporates load and performance testing into its suite of solutions, as well as security testing. Uh, you can do this in a number of different ways. You can do this by recording. a UI test and capturing the API calls from the front end to the services layer. You can do this by setting up proxies at various other uh, components within your system and capturing traffic there. You can do this by importing definition files or generating tests based on based on documentation. So all of these things are supported and they're easily automatable, right? So test automation here is the key driver. And so incorporating these tests into your CI/CD pipeline, into Jenkins, into GitHub Actions, Azure DevOps pipelines, really becomes key because then you can validate automatically and you can set these no go decisions based on your quality of service metrics or based on your SLAs and things like we talked about soak tests or peak tests. Those things are typically things that you can run continuously or things that you can incorporate into your test automation. You don't necessarily need to do a stress test every time you do a performance test, right? At certain points, you're just looking for trends and you're looking for consistency. We did um, a blog late last year about different strategies that you can implement in your continuous testing practices. We talked about the importance of investment in modernization of your infrastructure, but that modernization of infrastructure carries a lot of risk, right? Migrating off of legacy systems carries a lot of risk. So implementing these continuous performance testing strategies will actually allow you to detect any potential challenges or issues in those migration strategies and make it much safer for you to actually implement, more modern infrastructure technologies. On the other side of that is the test environment. So even if we actually have a fully configured automated performance test, we need to be sure that our environment is actually prepared to uh, to host these types of tests and actually is a realistic environment so that the data that we get from these tests is something actionable and something that we can use and we can iterate over. And there are a number of different challenges of why test environment stability continues to be an issue. We consider these the A, B, C, Ds of service virtualization. A is availability, so various components within the system simply not being available either due to being developed on a different schedule or uh, being something that we don't own in terms of our test environment. There are uncontrollable B behaviors, right? So anytime we want to simulate a specific behavior, a specific edge condition, maybe a performance delay, right? And we don't have control over those things in our test environment, that could be a challenge. C is cost. So any third-party application that provides a sandbox environment for us to test in will probably carry some sort of cost associated with that sandbox environment. So performance testing in those environments can become prohibitive pretty quickly as those costs skyrocket. And then finally is D, data, right? So data has to be consistent across the test environment. And with modern distributed microservices architectures, that means more individual components that need to be all synced up. There are traditional approaches to test data management, to test data availability that that aim to resolve these challenges, but as we'll see, they do not always ensure test data synchronization across all of our lower level environments. And in certain cases, it's just not enough data, right? Performance tests demand lots of data. So we need to be sure to account for that. That's where service virtualization comes in, right? So all those ABCDs that we listed, service virtualization allows you to create services, mocks, stubs, uh, data, um, basically anything within your component, any protocol within your component, any message format within your system that uh, that that is a blocker. You can simulate that and you can deploy it within your test environment. This gives you lots of configurability, gives you a lot of flexibility in terms of how you might want to deploy that service, what types of behaviors uh, to, uh, to demonstrate in the context of a either an automated test or a performance test, manual performance test, and really helps us resolve test environment stability, scalability challenges. And actually also provides us with safe test data, right? So when we have virtual assets that leverage virtual data, we can also reuse that virtual data within our tests, and that kind of helps us solve that issue. So how do we get here? Let's actually switch perspectives here for a second, and we will start with um, let's actually start with our application under test. So I mentioned, generating tests and creating tests um, based on capturing traffic. So this is actually something that we can do using our Parasoft recorder here. The Parasoft recorder allows you to capture API traffic in the browser. So this is traffic coming from the front end of the application. We're calling some services there. And if I go ahead and start recording here, and we will run one of our manual tests. So in this case, this demo application represents a camping store supply workflow. So, we might want to replenish our camp store supply and uh, order some backpacks for our store. So we can go ahead and do that. We got quite a few in stock here, so we'll add these items to our cart. Once we've added items to the cart, we can proceed to submit um, to submit a purchase, and we'll have to select a store here that we want to push these items to, and we'll give our receiver a name here, an invoice, and then let's generate an invoice number and a purchase order number. Okay, great. So this looks like our order here, 3 backpacks, and then we go ahead and submit this order for approval. So a flow like this, it's fairly easy to automate either using UI testing tools like Selenium or Selenic. Um, Parasoft also allows you to record UI actions within the browser and reuse those UI actions. But to test this application at a lower level, to test this application at an API level, or to automate this test, uh, with thousands of users, it is fairly resource intensive unless we dig a little bit deeper, right? Unless we dig a level deeper. And in our case, we can go ahead and stop recording. This is going to present us with a dialog box in terms of how we want to create a test here. We'll just call it demo app test. If we have a work item associated, like a Jira item, a requirement or a specific feature item that we want to attach to this test as metadata, we can go ahead and do that. And then we can go ahead and say create test asset. And so what that does for us is if we navigate now to SOA test, which is our functional testing tool, and we look at our test, we actually captured quite a few API calls here. And there's, you'll notice maybe some of these API calls, like BrightTalk, right? This is a BrightTalk webinar, so we'll see BrightTalk API calls here somewhere in my browser as I'm sharing my screen here, and we can filter these things out as well once we generate the test. But the actual underlying API calls, if we go ahead and expand these, we've done a few things here. Not only have we set up validation points for all of our data, right? If some data comes back, we actually have a diff tool that we can validate the response and make sure that it's a valid response, not just a 200 or some other status code. But we've also done all the stitching under the hood, right? So anytime you're doing any kind of API testing or you're doing an end-to-end scenario with API calls, one of the biggest challenges is being able to stitch together those API calls in a meaningful way. Tokens, IDs, names, various other components within the test flow need to be parameterized from one API call to another. And this is essentially what the tool does for you automatically. And it becomes even more important in a performance test scenario because, again, when we do this for 1,000 users or 100 users to generate some load, all of those things have to work, right? We can't just be using static IDs. We can't be using static, account IDs and things like that. Those have to be relevant in the context of the user that we're looking to simulate. So that's a very quick and easy way to get to a point where you have an automated functional test or an automated regression test, or converting a manual test into an automated test. But how do we take it and how do we convert it into a performance test now? So I have another example here. This bookstore test, and what we'll see here is, I've done something similar here. I've actually imported a definition file and I split up my test into a number of different scenarios. This is going to be really helpful for us in terms of creating uh, realistic use cases within our performance test. And this test file, this TST file, I can actually go ahead and I can import this file into my load test tool. We're just going to go ahead and grab the test here from where is it here? Let's find it. It's gonna be here. There it is. So I mentioned these different scenarios. What's nice about that is I can actually use each individual scenario as a different profile or a different virtual user. And if I go ahead and configure my test now, so if we look at, we'll do a steady load test, right? We'll do a simple soak test with a peak value of 4 virtual users. We can configure additional monitoring to maybe get some CPU or memory data and kind of really understand the performance of our application. We can also hook into things like App Dynamics or Dynatrace, as we're probably already using any of those technologies for monitoring. And then we have our quality of service metrics, right? So quality of service metrics is really where, from a test automation perspective, from a performance test automation perspective, we will we will need to use these metrics to validate whether or not our application performance is up to par, whether it meets the requirements of the SLAs, whether or not we are good to release into the next stage of the SDLC. If we want to simulate uh, these tests from some other geographical regions, we can add remote agents to generate load for us, and we also have a choice of how much data we want to record. Anytime you're doing a performance test, you want to be conscious of how much data you're capturing, as if you're capturing traffic for thousands of virtual users over the course of an hour, you're going to end up with way too much traffic. So there's some diminishing returns on that there, and keeping that in mind is important when running performance tests and analyzing results. And that actually does everything for me, right? That actually does all the setup. I'm able to reuse my tests from my functional tests. This is nice because it actually provides test engineers with a little bit more opportunity to have ownership of different types of tests. In terms of configuring the test itself, I might want to add a little ramp up here to the beginning of my test. And I also mentioned profiles. So these profiles, these scenarios that we defined within our test, uh, I can actually use these profiles and drive different ratios of load for each type of user, right? So for this bookstore, for example, I have users who are searching for books in my bookstore. I have users who are uh, buying books in the bookstore, and then I have users who are saving books for later. And so, in a realistic scenario, these values should change over time, right? If I have, for example, the vast majority of my users are going to be searching for books, and perhaps either saving them for later or um, or moving on. But at some point, I will have a sort of an increase in users who are actually buying books in my bookstore, and that might be correlated to some event, maybe a new, a new Harry Potter book, or some other event, right? That drives more users to my application. But in any case, I want to be able to simulate that. Or I want to be able to simulate these changes while I'm running my test. And so this is what we mean when we talk about realistic test scenarios. So with that in mind, to recap, what we've done here is we've used the Smart API test generator to generate some traffic. We've used SOA test to configure our functional test, and then we've been able to import this test um, into load test. We will take a look at a second here is the results, right, and being able to look at the results from test automation. But based on those results, based on those quality of service metrics, we can feed our dev team with actionable items, actionable results that they can then use to to make changes to the application in a time that is that is good for the organization. In terms of reporting, right? So these tests, I can run this test in the UI. I can run these tests in CLI. I can run these tests as a part of my pipeline. This test is now essentially fully automated. Um, and then when we look at the results for these tests, right? So when we run tests consistently, let's say we run this test weekly, which I've done here for the last few weeks, you can see the trends, you can see the results over time, and you can see one of the things that keeps happening here is I have one of my SLAs, I have one of my quality of service metrics that I am continuing to not hit. It always fails in these recent tests I run. And so I can actually drill into these reports. I can drill into the HTML report, which is going to have my SLAs. It's going to have my hit statistics. It's going to have success rates, percentiles, etc. Request sizes, right? All that necessary data. But I can also look at the history and I can look at the trends associated with these tests. And what the trend tells me is that there was a change at some point, quite some time ago, but nevertheless, I used to hit this SLA. We used to be able to meet this requirement and generate more than 11 hits per second. Um, but then something changed, right? And those changes, we want to detect these changes as early as possible, and this is exactly what test automation will allow us to do. Unfortunately, test automation requires software resiliency, right? So we've talked about that, and for a performance test, that can manifest itself in a number of different ways. So, an environment-based approach to testing means that our complete environment is in a ready state. We can leverage service virtualization here to ensure that. But in a performance test scenario, what happens is, we have our tests, we have our individual testers. We're again trying to simulate as real of tests as possible. So we're probably leveraging some test data management solution to import data from production or from copy data from production, and then synchronizing that data across all of our other services. Well, a distributed microservices architecture will have a number of different services, third-party services, services that perhaps are in sync from a test data perspective, and then there might be a service that, even with all the efforts and investments that we've made into our test data strategy, is still for some reason out of sync, right? And this is of course more of an issue for lower environments, right? Our prod environments will probably be synced up, but we can't always test performance test in our prod environments. We don't want to release defects into prod, so we don't want to test in prod either. So this is the first thing that we're going to address with service virtualization. If I navigate here to the environment manager, and we'll go ahead and actually drill into one of our systems, we can see one of my components here within my application under test is currently offline. And I know this because I actually have a health check that runs to validate the stability of that particular component. And it looks like it's failing with a 404. So if we actually look at our application under test here, and we're switching applications here. So we're looking at Parabank here, a little banking application, and this loan processor here. Let's say I want to um, validate the loan request function within Parabank. And I go ahead and submit a request here. I'm going to get some error, right? So this error is basically telling me that you can't run this test. Now imagine doing this, in the context of a performance test, or imagine either having this test run in automation and you get your results back, and well, all of your SLAs are failing. or if you're running a manual test and you've prepared your test environment, but for some reason it is simply out of sync with the rest of the test environment. You've planned for this performance test for months ahead, and now it has to be further delayed, and be a further blocker for the release of your application. Or at this point, you're releasing your application with whatever defects are there. So service virtualization allows you to take a more proactive approach to your environment stability. So for this loan processor, for example, I have a number of different virtual services that I can select to instantiate in terms of this environment. You can see I have some presets here for load and performance testing, which we'll cover here shortly. But I also have some presets that are maybe a little bit more static and just are there to give me what I need in order to um, in order to run my test. I can also do this with a complete test environment, right? So rather than individually selecting individual components and setting the state for those individual components, I can actually create an environment state and for example, an always positive state, right? One that will always serve me positive responses for for my loan processor, or a negative state, or a high latency state, or maybe some data driven state that maybe also changes our database to a virtual state, right? So this combination of being able to control individual services without having to redeploy them, as well as controlling the overall state of your system, is highly valuable to driving test automation and also making sure that your performance tests return reliable data. Also, it's important to note that this is something that you can do as a part of your CI/CD pipeline, right? So anything that you do in terms of deploying a virtual environment, you should be able to do that instantaneously before you kick off a test, before you kick off a performance test, an automated performance test, or a functional test, or a regression test. Basically, anything you do in the UI, you should be able to do in the pipeline, and you can do just that. So the second item here um, is in terms of test data quantity, right? So if we're actually doing performance testing, or if we want to do something like a stress test, or a spike test, right, or even a peak test, we will need a lot more data. And again, the traditional approach here to TDM is to copy production data, scrub it, subset some of that data, which we can actually use, which will allow us to synchronize across the envir- environment. And so what we end up with is we actually end up with potentially not enough data to test with. Maybe not enough credential combinations. Maybe not enough accounts for a particular user to do a particular flow. And that mean again, in a distributed microservices architecture, some services might be fine. They may not be so reliant on that test data, or being able to serve up responses for all that data. Maybe they're, an asynchronous service, or they are simply returning a static response there. But other services, especially third-party services, if you have, a sandbox, will probably limit you in terms of, what data is accessible to you. And then other components will, they have their own databases and also need to be populated and grown in terms of existing data sets. So this challenge here is something that we can address by leveraging service virtualization. So in my case, with Parabank here, let's actually configure this application to a state where the loan processor is live, but the database that we use to load accounts is actually virtual, or virtualized. And if we navigate back to the loan processor here and we just take a look at our accounts, we can see these are some virtualized accounts. And we know that they're virtualized because we can actually go in and we can make changes to these accounts. If we look at um, our data set here and we drill into it, um, this is my list of accounts, right? I can use this to validate various edge conditions. I can manipulate these numbers, and let's say we want to see how our application behaves with a large negative number in the account. Hopefully, this isn't your account. Um, but in any case, when we make changes here, we'll see these changes immediately reflected in our application under test. And we can actually see that there are some serialization issues. Again, hopefully this isn't your balance, but um, nevertheless, we should be rendering this amount correctly in this accounts overview page. Uh, the second part of this is the actual quantity of the test data itself, right? So currently we only have 4 accounts in our accounts overview here. We may want to actually increase that number to uh 40, right? Or obviously with a performance test we may be looking beyond those numbers. So to do that, we can actually drill into our data model here, and we actually what we've done here is we've inferred constraints for this particular data set. And we can go ahead and click on that, and what that will do is it will actually analyze the data, and it will tell us what are the limitations, what are the constraints of this data set. And then we can use these constraints to set mask and generate settings. So for example, let's say I want to generate 40 accounts with balances ranging from anywhere from -$1,000 to +$11,000. We'll use random mode for generation here. For the account IDs, perhaps we want them to generate in a sequence. So we'll just increment by one, starting with uh, account number 13000. And then finally, for the actual data set here, and the results, we currently have only 4 accounts, but let's say we want to set this to 40. Okay. So that's pretty much it. At this point, we can just go ahead and generate a brand new data set. Again, this is something that we can do as a part of our CI/CD process. We can generate these data sets on the fly. And once my data set, my new data set is generated, all I need to do at this point is update my virtual asset, my virtual service that's delivering this data back to the application, and set it to the newly generated repository here. So if I go ahead and refresh this page, we'll have 40 accounts, right? All these 40 accounts will have a variety of balances and available amounts. We can see our account increments by one, ranging from 13000 all the way to 13039. So this is a quick and easy way to actually grow your test data within your test environment, and forgo some of those constraints. Finally, let's talk about user experience validation, right? So, what we've kind of talked about so far is really a lot of API testing, backend testing, right? Being able to hit those services or simulate web API calls from the front end. But to validate real user experience, we have to validate their experience in the browser. And again, we can leverage technologies like SOA Test. SOA Test, has browser playback tools that allow you to run a browser test and validate on response times. We can also run Selenium tests, right? And Selenium comes with lots of features in terms of performance validation, end user validation, and sort of identifying degradation over time, or just generally validating the user experience there. But in order to do that, we will have to run thousands of browsers, right? So for every single user that we want to simulate, we'll have to have a browser that actually spins up and runs the test, so that we can test with the appropriate load on the system. And there's a number of ways to resolve that. One of those ways is through browser emulation, which is something that we do at Parasoft here as well. Another option is really to bite the bullet and uh, invest in lots and lots of infrastructure and computing power in order to actually spin up all of those browsers, or to do browser emulation. But a cost-effective way of converting your test environment into a test environment under load is really to leverage service virtualization, because our virtual services can be controlled. Our virtual services behavior can be controlled. So even though we're running a test in the browser, that doesn't mean that some of our backend services can't uh, uh, can't be modified to return greater response times or to behave a certain way under certain levels of stress, right? And this is where um, performance profiles really come into play, right? We can actually overlay these performance profiles onto a virtual service, and we can import this performance data from tools like App Dynamics or Dynatrace, or we can infer these performance profiles from the testing that we've done, right? So we've done some testing. We have response times available to us if we know a particular service that we want to emulate a specific behavior or a specific delay. We can actually do that within the tool. And if we actually switch perspectives here, if we look at virtualize, we can look at what these settings look like. I actually have a virtual service here, and this virtual service will have a performance option where we can set these things, where we can set values that for delays that might be load dependent. Um, we may actually have a fixed delay value and maybe add some randomization here. Um, and then we also have ranges. Um, and when we're between these ranges, right, we're going to get some sort of uniformly randomly distributed value um, between the things that we set. And if none of those things will capture all of your um, use cases, you can always script something, right? We support low code uh, like Groovy, JavaScript, Jython, right? You don't necessarily have to develop all of the characteristics of your virtual service. But you can add some custom behavior here. And so how that looks within our environment, right? We can just go ahead and navigate back to our environment manager here, right, where we're setting various states for our application. We can go ahead and add a load delay. We'll do a random anywhere from 5 to 10-second load delay. We'll actually go ahead and switch our database here to live again. Oh, let's go ahead and refresh this page. Uh, there it is. Oops. And actually, let's go ahead and also set this here. Great. So now if I navigate back to Parabank here and request a loan, and, you can think of this as a user experience validation test or a manual test or a Selenium test. At this point, I'm actually getting the delay from my backend service that I expected to get, right? Where we would actually wait. I think it would took like about 5 to 7 seconds, and then there's our response. We did notice certain delay drop. So, as we're approaching the end of our presentation here, just a few things to reemphasize. Number one, um, shift left your performance testing practices, right? So automate performance tests, leverage your test automation practices, leverage your automation tools to be able to reuse some of those tests for performance testing. This will allow you to do earlier stages performance testing, allow you to detect defects early. Maybe not all of the defects. You're certainly still going to be testing towards the end of the SDLC, but you will identify things and bottlenecks much earlier and fix them at a lesser cost. And in terms of solving your performance testing challenges using service virtualization, uh, do performance testing at lower levels of the test pyramid. Leverage test generation capabilities. Leverage the flexibility of virtual services to synchronize your components across your test environment, and also leverage service virtualization to simulate specific types of behaviors, delays within the system, within your environment, in order to do real end user experience validations. For more information, please feel free to scan the QR codes, download white papers from Parasoft, and now we'll get into some questions here. Okay, so we have a question here. I noticed that you're able to generate the test data as you're testing. Can you please tell me the name of the tool being used for this? So the tool that we're using, it's Parasoft Virtualize is the tool that we're using to virtualize components within the system, and we're using the TDM module of CT, which is Parasoft's continuous testing platform, to actually to actually generate the data. So TDM allows you to do data generation, subsetting, masking, infer constraints on data, morphing the data, geometry, right? So a lot of those kind of common TDM type activities that you can typically do with your test data. Great question. Okay, so some additional questions here. How does how does service virtualization handle more complex test logic under load? That's a great question. So, what I would recommend is actually taking a look at our service virtualization performance white paper. We've done some extensive testing with virtual services of varying complexity and how that complexity affects the the response delays, the response times, the transactions per second, the amount of load the virtual server can handle, um, uh, to sort of kind of give you an idea of the results that we came up with. Is although complexity does have an effect, you're probably not going to see that effect until very much higher rates of transactions. So I mean we've done cranked it up to 5,000, 10,000 transactions per second, and we have not seen performance degradation based on complexity of those virtual services. Of course, different organizations will have different use cases, different levels of complexity. But again, for more in-depth analysis on that, please take a look at our performance white paper for service virtualization. Another question here: what other protocols other than HTTP does load test support? Uh, SOA test and load test support over 120 different message formats and protocols. Obviously, if you're doing something like a browser UI recording, you're capturing HTTP calls. But within SOA test is a full, end-to-end testing solution. You can incorporate your database calls. You can incorporate Kafka, RabbitMQ, GraphQL, right? Anything that your application might be using, you can add test steps, which is really one of the benefits of reusing these types of tests for test automation. You can add various test steps to support the different technologies and protocols that your system under test is using, and chances are, whatever it is, we probably support it. Uh, Finally, last question: how virtual environments can be deployed dynamically into CI/CD pipeline. Another great question. Parasoft solutions do offer plugins into common CI/CD pipeline solutions like Jenkins, GitHub Actions, Azure DevOps, Bamboo. Uh, but we also expose REST API. So anything that you can do via UI, you can pretty much do via REST API, and that's a very straightforward way of incorporating dynamic virtual environments into your CI/CD pipelines. With that, we are out of time. We're actually past time. So if you've hung on with us here, thank you for staying. Thank you for your questions. Please feel free to reach out with any additional questions, and take a look at all the information available on Parasoft.com to further learn about this topic and how service virtualization can can help your organization. Thank you, and we'll see you next time.